Hello everyone, this is Sapna Pawar. Today I am going to explain task-based application model under the guidance of Sudha ma'am. In task-based application model, we have four types: embarrassingly parallel application, uh, parameter sweep application, MPI applications, and workflow application with task dependency. Let us go with embarrassingly parallel model. It is most simple and intuitive category. Here we have collection of tasks which are independent of each other and they can be executed in any order. Those tasks may be of same type or they may be of different type. They do not need communication among themselves. So there is a lot of freedom regarding how they are scheduled, and there is no specific requirement for the task to be executed at the same time. And for this schedulement, we need an optimal mapping of task to available resources. The frameworks which support embarrassingly parallel models are Globus Toolkit, BOINC, and Aneka. The problems that can be modeled are image and video rendering, evolutionary optimization, and model forecasting. Let us go to second one, that is parameter sweep application. This is a specific class of embarrassingly parallel application. Here the tasks are identical in nature and they differ only by some specific parameters and used to execute them. This is different identified by template task and set of parameters. Combination of parameters together with their range of admissible values identifies the multidimensional domain of the application, and each point in this domain identifies task. Only difference is that the tasks that will be executed are generated by iterating over all the possible and admissible combinations of parameters. Any framework which supports the embarrassingly parallel applications will also support the parameter sweep applications, like we have seen here. Globus Toolkit and Bionic, this all support here in parameter. Nimrod G is natively designed to support execution of parameter sweep application. Here we have a template task is often expressed as a simple file command. Those commands are execution, which will execute the program on the remote node. The second one is copies, which copies the file or the document to or from the remote node. Third one is a substitutes the parameter values with their placeholders inside the file. Fourth one is it will delete the file. Moving on to MPI application, which stands for Message Passing Interface, is a specification for developing parallel program that communicates by exchanging messages. Here we need the communication, and MPI introduces the concept of communication that invokes the task to be executed at the same time. And MP has become a de facto standard for developing portable and efficient message passing HPC application. It is defined and implemented in C, C++, and Fortran. MPI provides developer with set of routines that are: it will manage the distributed environment where MPI programs are executed, provide facilitates for point-to-point communication, provide facilities for group communication, provide support for data structure definition and memory allocation, provides basic support for synchronization with blocking calls. So here is a diagram for MPI reference scenario. We have a MPI communication world. This 0, 1, 6, these are all identifiers. Next we have two groups, group 1, here you can see group 1, and group 2. These two groups, they have their own rankings, like 0, 3, 9, 7 in group 1, and in group 2, 1, 2, 4. These will be connected to MPI common world, and the communication between them will be facilitated by communicator 1, communicator B respectively, communicator A. So this is a MPI program structure. First we have to include the files, MPI files. Then a prototype declaration should be done in the program. Next, do work, like MPI environment initialization. We should initialize the program. We need to do the work and message passing. Next we have to shut down and do the work. The first one is a header section. The remaining is a code section. Now moving on to workflow application with task dependency. Workflow is a automation of business process in whole or part, during which document information or tasks are passed from one particular to another for action according to set of procedural rules, useful for expressing specific experiments, and give birth to the idea of scientific workflow. A scientific workflow generally involves data management, analysis, simulation, and middleware supporting the execution of the workflow. A specific scientific workflow is generally expressed by a DAG, which is a directed acyclic graph, which defines the dependencies among the tasks or the operations. The nodes on the DAG represents the task to be executed in the workflow application. The arcs, these nodes, you can see here in the diagrams, those lines will be, sorry, those circles will be, nodes are task, and the arcs, lines connecting the nodes, identifies the dependencies. Those lines will specify the dependency of the task among themselves. So this is 7.6 is a sample mortgage workflows. First we have to transfer the template header. First single template header is to be transported. Next we transport 7 images, and we have to create the mosaic of those images into mosaics, and then we need to reproject those images, and the difference between the reprojected image and the original transferred image is calculated in the next step, that is calculating the difference. We fit a common plane for those images. We see the background modeling. Any corrections in the background will be done in the next step, that is background correction. Next, we add those images into final mosaics with similar characteristics. Later, we register the mosaic. Thank you, everyone.